All right, in this video, I will spend just a little bit of time talking about exponents. We actually already did this in section 5.2. In this section, we're just going to talk about a few things we need to know as we head into scientific notation. So first of all, we said the definition of x to the n power means multiply x n times. That's what it means when you apply an exponent. So for example, if you have y to the third power, or y cubed, that means multiply 3 fours, and you get 64. All right, let's look at some other problems. So the first one is 19 to the 0 power. Now we'll talk about the answer here in more detail in just a few minutes, but anything to the 0 power is actually 1. Whoops, I'm sorry, I just hit the wrong button. So 19 to the 0 power is 1. Anything to the 0 power is 1. Now, if you look at the next two problems, we have negative 12 to the 0 power and negative 12 to the 0 power. And we talked about this in that previous section. When you're dealing with exponents, it's very important that you know what your base is. So when you have an exponent, it only applies to the number or letter that it's next to unless you have parentheses. So in negative 4 squared, this first case here, this is actually equal to negative 4 times 4. In other words, we're going to square 4 first. 4 is my base. And then we're going to apply a negative to it. So here we're going to get negative 16 because 4 times 4 is 16. And then we apply the negative. The other way to think about it is we're multiplying negative 1 times what we get when we multiply 4 times 4. Now, in the other case, the base is everything underneath or inside the parentheses. And so here we're squaring negative 4. Whoops. So we're going to multiply two negative 4s. And we know a negative times a negative is a positive. So that you can see it's important that you know what your base is. We get two different answers with these, just like we will on number 2. So on number 2 here, we're going to take negative 12 to the 0 power, and we know anything to the 0 power is 1. Any base to the 0 power is 1. Now on number 3, though, our base is just the 12. And so we're basically going to take 12 to the 0 power, and then we're going to apply a negative or basically multiply by negative 1. Well, 12 to the 0 power is 1, and 1 times negative 1 is negative 1. So notice we do get a different answer than we did in problem number 2. All right, let's move on to the next slide. And here we have x cubed times x to the 5th. Now there's a property for exponents. It's a to the m times a to the n is equal to a to the m plus n power. So you can see in this problem, all we need to do is add the exponents. We're going to get x to the 8th power. 3 plus 5 is 8. Now, it's really not hard to believe this rule is what it is. If you think about it, x cubed means 3x is multiplied, and x to the 5th means 5x is multiplied. And so you can see there's a total of 8x's multiplied. Again, the shortcut is to just add the exponents. All right, let's move on to the next problem. So here you have 10 to the 4th times 10 to the 7th. You should go ahead and answer that. All right, let's see how you did. Of course, you're just keeping the same base, and you're adding the exponents. 4 plus 7 is 11. So 10 to the 11th power. Let's move on to number 6. So this time we have a division. Now, if you look back to what we were just doing, when we multiply two powers, we add the exponents. So what do you think we're going to do when we divide two powers? Well, we'll do the opposite thing. Since multiplication and division are opposites, we're going to subtract the exponents. And so we get x to the 8 minus 2 power, or x to the 6th. The property that we're using is a to the m over a to the n equals a to the m minus n. So if you divide two powers, you just subtract the exponents. Just like when you multiply two powers, you add the exponents. So again, they're opposites. Now, I want to go back to something I said earlier. I said a to the 0 power is 1, or anything to the 0 power is 1. One way that I could show you that, and there are others, but this will be good for now, is if you had x to the 5th over x to the 5th, well, that would be x to the 5 minus 5 power, which is x to the 0 power. On the other hand, we also know that anything divided by itself is 1. And so you can see from what we've done here, it's reasonable that anything to the 0 power would equal 1, just by looking at our quotient rule. All right, last problem, 10 to the 6th over 10 to the 3rd. You should have subtracted the exponent, 6 minus 3, you're going to get 10 cubed. All right, and that's really all that we're going to need for what we're going to be doing with scientific notation in terms of exponents. All right.